One of the most striking puzzles is found in people who appear to function normally, even though brain scans suggest that most of what we expect to see simply isn't there. Imagine being told after decades of ordinary life, holding a job, raising children, staying active in your community, that your cranial cavity is largely filled with fluid rather than brain tissue. At first, the claim sounds impossible. Without the billions of neurons and folded cortex thought to underlie awareness, how could coherent speech, memory, or reasoning persist? And yet, some documented cases show exactly that. Individuals with scans dominated by fluid rather than tissue, who nonetheless live in ways indistinguishable from anyone else. These examples remain rare, but they have been continually cited in medical literature as puzzling counterpoints to traditional models. The condition most often connected to such accounts is hydrocephalus, where cerebrospinal fluid builds up inside the skull and compresses the brain outward into thinner layers. Typically, these patients are expected to have major limitations, developmental delays in children, or marked cognitive impairments in adults. Yet in certain cases, despite severe anatomical changes, patients learn, work, speak, and think with apparent ease. The surviving tissue, often pressed against the skull like a narrow lining, manages to stay in capacities once thought impossible to compress into so little space. Observers are struck by the mismatch, images showing wide cavities, alongside living people conversing effortlessly about their day. Mainstream neuroscience does not ignore these cases. Researchers emphasize established explanations such as the brain's remarkable plasticity, especially when changes evolve slowly over years. Neural networks can reorganize, shifting function into smaller remaining areas. The spare cortex, though reduced in volume, may shoulder far more responsibility than expected, reorganizing in ways we do not yet fully understand. These clinical explanations ground the mystery, reminding us that the brain is adaptive tissue rather than static architecture, and that extraordinary compensation is sometimes possible. Awareness of related conditions is also growing. In older adults, a specific form known as normal pressure hydrocephalus, NPH. It often presents with unsteady gait, memory issues, and incontinence, and is frequently underdiagnosed. Some estimates suggest many thousands of people in the United States may live with untreated NPH, and specialized programs now focus on shunting procedures that can restore function. Adding this clinical backdrop helps place the rare, dramatic cases of near-normal function with minimal tissue within a much larger picture. Fluid buildup in the brain is not unheard of, and conditions tied to it occupy active fields of research and treatment. Even with these explanations in mind, the day-to-day lives of certain patients remain startling. Medical journals describe adults learning their diagnosis by chance, perhaps during imaging for headaches, only to discover their scans look nothing like medical textbooks. Friends and family often report no signs of impairment. Children diagnosed much earlier sometimes surprise teachers by keeping pace in classrooms, despite dire predictions. For many, the discrepancy between what the scans show and what life reveals is hard to reconcile. Photographs of ventricles enlarged to cavernous size are paired with reports of people going to work, watching sports, or making dinner. The scientific implications continue to press on long-held assumptions. If calculating brain volume does not linearly translate into cognitive ability, then the standard formula, more tissue equals more function, less tissue equals less function, cannot be fully correct. This mismatch has led to pointed questions. Is there a yet unseen efficiency principle by which neural tissue reorganizes under extreme circumstances? Are networks capable of compression so extensive that a sliver of cortex can represent the work of billions of neurons? Or perhaps most provocatively, are we still missing something larger about the relationship between tissue and consciousness itself? Not all cases are so favorable. Many. Individuals with hydrocephalus do face serious impairments, and the condition can be life-threatening without treatment. The high-functioning examples must therefore be understood within that wider context. Even so, the accumulation of examples, particularly as scanning technology improves, has shifted tone. These reports are no longer dismissed as one-off anomalies whispered among specialists. By 2025, enough evidence had been reviewed to show that while they remain statistically rare, they appear consistently enough to warrant systematic attention. Researchers now group these cases as a category worth structured investigation rather than merely oddities in the margins. For physicians, the encounter with such patients can provoke a blend of admiration and unease. Admiration for human resilience and the adaptability of neural tissue, unease because each instance complicates the neat framework used to teach students how the brain generates mind. Tissue volume is easy to quantify. But when life continues with a fraction of the expected material, numbers lose their tiny predictive power. The assumption of direct proportion between anatomy and consciousness falters, and with it, some of the confidence that brain scans can tell us all we need to know about inner life. What lingers most is not the medical strangeness, but the ordinariness of those living it. They shop, argue, laugh, and sleep as anyone would. Looking at them, nothing betrays the unconventional architecture hidden beneath the skull. The reality of their daily presence challenges every easy metric. It suggests that identity and awareness do not reduce so cleanly into matter, and that lived experience often resists simple mapping. The contrast between hollow images on a scan and full lives unfold in the world leaves medicine with a puzzle that remains unresolved. And unresolved puzzles have a way of multiplying. If a person can think clearly with far less neural tissue than assumed possible, it invites us to reconsider what clarity itself really is, and when it can appear. Doctors sometimes witness moments even more confounding than long-term stability on thin layers of cortex, sudden returns of lucidity in conditions thought far beyond repair. Those fleeting spark-like intervals raise the same fundamental riddle in a new form, turning the spotlight toward consciousness at its most mysterious. The lantern that flares one last time. There is a phenomenon that unsettles even the most experienced physicians and caregivers. After years of slow decline into silence brought on by dementia, speech suddenly returns. A person who had long ceased to recognize family, who could no longer form sentences or recall names, sits up and speaks with clarity. They may ask questions, recall stories, or express affection thought lost forever. This renewed coherence most often occurs not randomly, but in the hours or days immediately preceding death. The paradox is unsettling. The mind appears vivid and aware at precisely the moment when the body and brain are least capable of sustaining function. Clinicians have given this strange occurrence a name, terminal lucidity, and in 2025 it is increasingly a subject of serious scientific study. One case described this year involved a woman with advanced Alzheimer's disease who had been almost entirely nonverbal for a decade. Caregivers reported only occasional murmurs, rarely coherent words. Then, one morning, she astonished her family by greeting each of her children by name. She asked them to sit close, gave advice about their lives, and even shared a joke she had repeated often in her younger years. Less than a day later, she passed away. Physicians found it difficult to reconcile such fluent and emotionally rich interaction with the extensive atrophy shown in her brain scans. By medical expectation, she should not have had the capacity for such conversation. The story is deeply moving, yet researchers caution that family memories can amplify the event in hindsight, creating a risk of selective recall when such moments are retold later in interviews and reviews. Another documented case comes from a patient with Lewy body dementia. After years haunted by confusion and hallucinations, and with limited coherent speech, he suddenly asked if they could move the piano nearer. To everyone's astonishment, he sat down and played a melody he had learned in his youth. Though his hands had long been stiff, his fingers moved across the keys with fluency that had seemed impossible for years. He then looked up, thanked his family, and passed away later that day. For neurologists, musical performance of this kind represents highly organized action. The contradiction presses the same question: how can such coordination appear at the edge of life when the brain is most impaired? Here again, scientists note that moments like these come to us largely through retrospective reports, and while the narratives feel trustworthy, they remain anecdotal until paired with systematic observation. Until recently, terminal lucidity was treated primarily as personal testimony, moving and unforgettable but scientifically fragile. In 2025, however, researchers have begun collecting data in more structured ways. Hospice staff and memory ward caregivers have provided surveys that catalog dozens of cases. Pilot studies show that many clinicians across countries report witnessing at least one such event in their careers. Psychologist Michael Nam and colleagues drew attention to these stories years ago, and more recently, Alexander Bathiani's survey suggested that terminal lucidity might appear in a few percent of dementia cases observed in hospice settings. Estimates still vary widely. Some researchers report these modest percentages in clinical samples, while others urge caution, stressing that more systematic methods are needed to verify true frequency. What unites these efforts is an emerging consensus. The phenomenon is not a one-off rarity, but a repeated observable feature of the dying process in some patients. The contradiction lies in how neurodegenerative disease is understood. Alzheimer's, Parkinson's, and other dementias are characterized by shrinking brain regions, tangles of abnormal proteins, and progressive loss of neurons. Scans show clear decay, and in most of the course of illness, function steadily withdraws in parallel. Yet in the final stage, in a small subset of people, memory, recognition, and language reappear. Patients laugh suddenly, embrace family with awareness, or speak meaningful words in voices that had long been silent. Simple models of anatomy and function predict that such recoveries should be impossible. Yet the stories and now systematic surveys insist that something happens as the end draws near that does not fit well with present assumptions. Researchers continue to propose mechanisms that might explain these last bursts. Some suggest that biochemical surges in the dying brain provide temporary stimulation to networks that had been silent. Oxygen deprivation and energy failure may push remaining neurons into unusual activity, producing short-lived windows of function. Others hypothesize electrical discharges that sweep across fragile circuits, lighting them briefly before collapse. Another possibility is that small pockets of neural tissue survive longer than scans indicate, holding just enough capacity to support a pattern release of memory or speech when triggered by dying brain chemistry. These hypotheses remain speculative. They attempt to ground the paradox within known processes, but as of now, none fully accounts for the depth or coherence of some reports. For some scientists, these explanations remain too narrow. They ask whether the phenomenon suggests that awareness may not directly equate to visible tissue condition. If advanced atrophy still permits coherent thought under certain conditions, then the mapping of structure to consciousness is more flexible than our current measurements suggest. Others go further, raising the idea that the brain might in certain circumstances act as a receiver or conduit for patterns of awareness rather than as the sole generator. While these ideas are more radical, their presence in peer-reviewed discussion reflects how terminal lucidity presses against our usual boundaries of explanation. Yet for families, scientific framing matters less than the lived moment. A father recognizing his daughter, or a wife saying, "I love you" with full clarity after years of silence becomes a memory that defines how the final hours are remembered. Caregivers regularly describe the atmosphere of such moments, how the room itself feels changed as words return. Nurses and doctors, though trained to be clinically detached, still admit their surprise when seeing language reemerge moments before death. These experiences ring as genuine to those present, even as research emphasized the need for cautious interpretation. The recent reviews emphasize not only collecting testimonies, but also improving methods of study. Researchers are now developing observational protocols in hospices and hospitals to prospectively track signs of lucidity as patients near death. Multi-center studies are underway, aiming to standardize documentation and collect biomarkers, such as EEG activity, heart rate changes, or oxygen levels at the time events occur. This structured data could clarify whether terminal lucidity is tied to distinct physiological signatures, advancing understanding beyond anecdote. Terminal lucidity remains unpredictable, sometimes lasting for minutes, rarely for days, and often not appearing at all. Its timing is irregular, its triggers unclear. The uncertainty makes it difficult for doctors or families to expect it. Its recurrence across countries and care settings makes denial harder. The metaphor often invoked is that of a lantern glowing brighter just before it extinguishes. Science now seeks to measure how and why that glow occurs, but much about it remains hidden. The persistence of this mystery leads naturally to a deeper question. If consciousness can surface strongly in brains judged to be too damaged to sustain it, then perhaps our measurements are too blunt to capture what is unfolding inside. And if our instruments can miss such vivid displays at life's end, it raises a troubling possibility. Might they also fall short in other states where awareness is presumed absent? Awareness where monitors say none. Imagine lying unconscious on an operating table, the monitors showing silence from your brain, while later you recall precise details of what happened in the room. There are credible reports of patients repeating words spoken by surgeons or describing events from periods when monitoring suggested low or absent activity. This mismatch between lived recall and machine readings has prompted rigorous study rather than easy dismissal. For decades, many assumed a flatline equaled no possibility of awareness. But mounting accounts and the data that now accompany some of them indicate that consciousness may persist in ways standard equipment has struggled to detect. By 2025, advances in monitoring have made it possible to capture activity that older machines smoothed out or missed entirely. Researchers now report that under anesthesia, during cardiac arrest, or in the first moments after resuscitation, tiny sparks of neural firing appear. These are not broad waves sweeping across the cortex, but short bursts, tightly localized, and easily hidden within coarse recordings. Some patients describing operating room conversations or specific sounds later align their memories with these bursts, suggesting fragile but genuine traces of awareness survive beneath the supposed silence. The puzzle grows sharper when examining timing. A few bursts have been recorded seconds after brain readings appeared flat. Standard models long held that once generalized silence set in, coherent experience was impossible. Yet patients recount impressions pegged to those very moments, the sound of instruments clattering, the rhythm of music playing, or even whispered remarks between anesthesiologists. What unnerves researchers is that medical staff often confirm these details independently, lending credibility to patient memories that should not have been possible under complete unconsciousness. In surgeries involving deep anesthesia, this problem is even clearer. Patients emerge describing staff conversations or the sequence of surgical steps with accuracy. Past explanations claim these memories came from moments on the edge of waking or from suggestions after the fact. Yet recordings from fine-grained instruments now show subtle bursts of activity occurring well before anesthetic emergence. Like faint currents moving beneath still water, these bursts suggest neural coordination continues on scales too brief or local for traditional EEGs to register. Families naturally find such accounts startling. A patient recalling the blue tool placed on a tray or the line of a joke made at the operating table is not easily dismissed as imagination. In several cases, these details were only known to staff present in the room, yet they surfaced in patients whose monitoring suggested none of it should have been perceptible. For relatives, the contradiction is stark, the authority of machines on one hand, the vivid testimony of their loved one on the other. This raised the question of whether long-trusted equipment has been missing too much. Traditional EEG measures broad oscillations, treating consciousness as a large-scale rhythm. In truth, awareness may unfold in fleeting configurations between smaller circuits, quickly changing and impossible to catch with such averages. With newer high-resolution devices in 2025, hospitals now report glimpses of these microbursts, indicating that some patients may pass through hidden states of awareness even when clinical tools show oblivion. The implications are immediate for anesthesiology. If a flatline no longer guarantees the absence of perception, then the safety protocols built on that assumption demand revision. Some specialists now look for subtler signatures in brain signals, faint hints that sensory impressions may still seep through. It suggests that the clear borders we thought separated consciousness from unconsciousness might be edges we drew only because of the bluntness of our instruments. The debates intersect with another field, often dismissed in the past, near-death experiences. For many years, reports of tunnels, lights, or encounters during cardiac arrest were ascribed to hallucination or flawed memory. Today, with new recordings showing short-lived sparks in flatline patients, these narratives carry new weight. Researchers note that while subjective, such reports are beginning to align with faint physiological traces,
rather than occurring in an explanatory vacuum. Some experimental work has also sought to replicate similar conditions. Recent studies inducing temporary syncope in volunteers, essentially causing brief loss of consciousness through blood pressure manipulation, have produced NDE-like reports in a substantial minority of participants.
These results suggest physiological pathways, such as oxygen deprivation and neurotransmitter surges, can generate experiences strongly resembling accounts from cardiac arrest survivors. Though not conclusive, these findings support models placing biological processes at the center of such phenomena rather than treating them as entirely separate from brain function. In line with this, several theoretical models attempt to frame mechanisms more precisely. One example published in recent years is the Neptune model, which proposes cascade processes involving declining neural activity, sudden neurotransmitter release, and disinhibition that together sustain brief but vivid conscious states. Other work, such as models proposed by Charlotte Marshall and colleagues, suggest near-death experiences may arise through complex transitions between networks under stress without resorting to explanations beyond neurophysiology. These hypotheses remain under active evaluation, offering grounded accounts without leaping to metaphysics. Alongside these advances, researchers remind us that testing for hidden awareness directly has proven difficult. Some resuscitation studies placed visual targets high above patients, attempting to verify whether out-of-body reports corresponded to actual external perception. To date, such trials have produced no conclusive evidence. Testimony of vision during cardiac arrest has yet to match controlled targets, leaving the question of whether veridical perception occurs unresolved. Scientists emphasize this gap, cautioning against overstating what current data supports. Still, the combination of refined monitoring, case reports, and experimental analogs point in the same direction. The brain's apparent silence may conceal fragile but meaningful sparks. Patients who later describe perceptual fragments, families grappling with uncanny accuracy in the accounts, and doctors rereading their machine readouts all share in the recognition that our tools have limits. Traditional equipment has been reliable for many tasks, but in estimating whether consciousness endures, it may be too blunt an instrument. The phenomenon also has personal dimensions. Many patients describe awareness during supposed unconsciousness as unsettling. Some carry distress for years, experiencing anxiety about future procedures. Others speak of the experience as clarifying, a glimpse at the threshold of awareness that shifted how they saw life afterward. Whatever the emotion, the persistence of these memories underscores their reality to the people who lived them. Reconciliation then falls to science, which must find ways to measure what has long been only reported. As new instruments enter hospitals, reports of hidden bursts seem increasingly common. ICU staff, anesthesiologists, and resuscitation teams are finding patterns they once thought impossible. The story that states of consciousness are a simple on or off binary appears increasingly unrealistic. Better measurement reveals gradations, transitional zones, and moments of unexpected coherence. Where machines once told us there was nothing, we now see faint signatures that make us question the reliability of maps drawn from incomplete data.